So I'm going to finish up the videos for solving rational equations with this one. These are about as hard as they get because you have a number of fractions which don't have common denominators, and not only that, but you have some of those variables up top. So I think this is going to end up generating a quadratic. We'll have a number of solutions to check, so let's just get going with this. And first step, remember what we always do in the first step, factor your equation. So I have phi, let's see, what's this going to be? Phi minus 3. I don't know why that one confused me for a second. 5 minus 3 and 5 minus 1, especially considering the answers are right over here. That's embarrassing. If you get stuck with factoring, always check the other fractions, because there might be an answer sitting right there if you just can look an inch to the right. Okay, so I'm going to keep on writing here. 5 over 5 minus 1 and plus 5 minus 4 over 5 minus 3. And let's just move this guy over a little bit. I want to have room for what we need to do next. So there are a bunch of denominators which are missing factors. So if you take a look at this guy right here, you can see it's missing a factor of phi minus 3. So I'm just going to add that in there. Phi minus 3, phi minus 3. I'm multiplying top and bottom of the fraction by phi minus 3. That means it's a crazy 1, right? This is equivalent to multiplying it by 1. And likewise, on the right, I'm going to multiply this one by phi minus 1. Okay, it's another crazy 1. And I think by the time we carry this all through, I know we'll have common denominators, because now look, everything has phi minus 1, phi minus 3. Okay, so what do we have here? Negative 10 over the denominator. I suppose we better, for completeness, just write this all out, equals, and let's carry these through, 5 phi minus 15. Careful of things like multiplication errors or minus sign errors while you're doing this, because it's surprisingly common. When you're thinking about complicated things, you make dumb mistakes along the way, and it's kind of annoying to find it afterwards, like, oh, I slipped on a minus sign. Isn't that great? Okay, so phi minus 3 and phi minus 1. I'm all done. So because the denominators are all equal, I'm just going to come through here and cancel them all out. I can do that because it's an equation. Don't try this with regular fractions, but once you see that equal sign in an equation, you can get away with a lot of stuff. So minus 10 equals 5 phi minus 15 plus, a lot of stuff here, phi squared minus 5 phi plus 4. And now because I see that there's a quadratic term here, remember I had a feeling this was going to happen. That's a quadratic term. There's linear terms right there. I'm going to try to group this so that everything is on one side and 0 is on the other. Okay, so I'm going to bring that 10 over here. Let's just say 10 plus 5 phi minus 15 plus phi squared minus 5 phi plus 4. And now it's time to group our common terms together. I see a 5 phi and a negative 5 phi, so those cancel out. That's nice. What else do we have here? I see a positive 10, a negative 15, and a positive 4. So that comes out to 14 minus 15. That's going to be a negative 1. And what else is going on? Well, there's just that phi squared. So phi squared minus 1 equals 0. I sure hope you guys can factor this one. It's phi minus 1, phi plus 1. That's our equation. This is what it's equivalent to. Got a lot simpler from that earlier one, right? So what are my two solutions? Well, from this part right here, I get phi equals 1. From this part right here, I get phi equals negative 1. So those are good solutions. Let's see if they work. We never checked the domain restrictions, or we forgot to earlier. Remember what domain restrictions are. That's where your denominator would equal 0. So from this one right here, I'm going to say phi cannot equal 1. Okay, and from this other one right here, I'm going to say phi cannot equal positive 3. So let's think about that and compare it to what we just got down here. And you see one of these does not work. Okay, so that is an extraneous solution. And we only have one solution that works. Here's our final answer for this problem. Phi equals negative 1. and we're done.